When people find out I'm a geologist, they frequently ask me about finding things of value. If my wife's around, she'll chime in. You're always doing field work. How come you never find anything valuable? I always tell her that I found her, and that is something really valuable. So, plus points for me. But human beings have valued gemstones throughout history. Gems can be spectacularly beautiful, but like all tastes in gems have also changed in the last few decades. With increasing numbers of people searching for gemstones in the last 2 or 3 decades, the expansion of the gemstone industry and the continually evolving styles of jewelry, there has been a kind of reinterpretation of what geologic materials are both valuable and beautiful. Let's start with the basics. Gems, in the traditional sense, were mostly considered to be specific mineral types that occur in a unique form or color. Crystal characteristics, which are determined by the mineral structure, are the foundation of a gem. The gem's beauty is enhanced by cutting and polishing. Because most of the appearance of a gem is brought out by the trained professionals who make gemstones, people don't know that in the field, a gemstone looks like any other rock. As a result, they are difficult to find. And how the raw gem is obtained is another large part of what makes gems valuable. Gemstones used to be rigidly divided into precious gems and semi-precious gems. The precious gems included minerals that were, of course, valuable, but also had durability and were especially difficult to find. Their hardness and rarity increased their value. Examples of what have been traditionally called precious gems include diamonds, emeralds, which are a type of mineral beryl, ruby, which is the mineral corundum, and sapphire, which is also corundum. The durability of the precious gems is reflected in the mineral hardness. Diamond has a hardness of 10 on the Mohs hardness scale, and corundum has a hardness of 9. Diamond and corundum are among the hardest minerals found. Beryl has a hardness of 8. Another one of the traditionally precious gemstones is opal. Opal has a hardness of around 6, but its amazing color and luster made it a very highly valued gemstone. But questions abound when you think about the designation precious. Green-colored beryl is emerald, but when it's a lighter colored, it's aquamarine. Aquamarine is considered semi-precious, and emerald is precious. Why? It's the fickle nature of gemstones. The list of semi-precious stones is long, and to some degree, it keeps growing as different materials are used as gemstones. That is, not just minerals are used as gemstone. Many semi-precious stones are amazingly beautiful. Quartz has a hardness of 7, but it can take on a variety of beautiful colors. A personal favorite of mine is amethyst. Amethyst is a purple version of quartz. The yellow version of quartz is citrine. It's also semi-precious. Even some brown-colored quartz is used for the gem called smoky quartz. Some gems are valued for their crystalline nature along with color. Garnet is a dark, dense mineral whose names come from the resemblance of red garnet to the seeds of a pomegranate fruit. In the end, the terms precious and semi-precious have no clear definitions. Some gemstones, which are considered semi-precious, can be quite valuable. Forbes magazine listed the 10 most valuable gemstones. Diamond, specifically red diamond, is at the top of the list. But also on the list are alexandrite, which is another type of chrysoberyl, and red beryl. It's hard to figure. Minerals that are capable of becoming gemstones form in different environments. In other words, you don't find all gems in all places. The geology of an area limits what gems will occur in that region. Take some world-famous gems, for example. Diamonds come from deep mines in Africa. Ruby comes from Myanmar. Turquoise comes from southwestern United States. And great amethyst can be found near the land surface in Brazil. So understanding how gemstones form will help you understand where to find them. There are 6 ways gemstone minerals form. Let's start with the gemstones that form closest to the Earth's surface, where pressures and temperatures are lowest. There is a bit of a basket term for gemstones that form near the Earth's surface, and that's called a sedimentary process. These gems form from the precipitation or crystallization of minerals or mineral material as water moves through rocks and into open spaces in the rocks. Geodes are a common example, and amethyst is a unique type of geode. Water moving through silica-rich rocks becomes saturated in silica. When an open space is encountered, the partial pressure of the water changes and silica begins to crystallize. In the case of Brazilian geodes, the open spaces form as gas bubbles in basalt. The amethyst grows with space, time, and a continual supply of its silica-rich ingredient. Agates are a sedimentary gem, but the individual silica crystals are much smaller than the crystals that grow in geodes. Because the crystals are smaller, they coat the inside of the gas bubble, called a vug. This creates layers of accumulating silica that is white or clear with varying colors, depending on impurities. For example, iron will stain the layers red. If there's copper in the rocks that the water is passing through, then azurite might form instead of agate. If there's copper but even smaller crystals form, then the resulting gem is malachite. Turquoise is a sedimentary gem as well, but turquoise is deposited in fractures rather than volcanic gas bubbles. In large openings, turquoise has been known to form stalactites. Turquoise is a copper aluminum phosphate, and frequently turquoise is found in association with copper deposits. Turquoise is one of the oldest mined gemstones in the world. Opal also forms as a silica precipitate, but it's a little bit different. Opal is a non-crystalline gemstone, and it forms from the lithification of silica spheres. Because opal forms very near the Earth's surface, only around 100 feet deep, climate conditions influence its formation. The right variation in temperature and rainfall, along with the right geology, are necessary. The process takes millions of years for gem-quality opal. You need uniform silica spheres, and it seems the best size of those spheres is between 152 and 400 microns. At this size, the diffraction of light is especially unique and especially valuable. So if you're looking for sedimentary gemstones, a good place to start would be rocks with lots of holes in them. So for example, a basalt flow that formed millions of years ago was buried and then re-exhumed by erosional processes might be a good place to poke around. A second way that gem-quality minerals crystallize is through hydrothermal processes. High-temperature waters associated with magma have the ability to pick up chemicals. If those waters reach an open space where crystals have space to grow, you can get the formation of gems. Beryl is a family of silicate gems with beryllium. The most famous beryl is emerald, which owes its green colors to chromium or vanadium. A third way gems form is in the late stages of crystallization of magma. Many unique minerals form in a rock called pegmatite. Tourmaline is one important gemstone that forms this way. Tourmaline itself is a family of silicate gems that have boron in them and that can result in some interesting and beautiful colors. Other gems form by magmatic processes, including zircon, topaz, and rubies. These are brought to the surface by volcanism, whether basaltic volcanism or alkaline volcanism. So extrusive igneous rock terrains can be a place to look for gemstones. Most people would argue that the majority of gems are found in metamorphic terrains, The high temperatures and high pressures generated during metamorphism result in the recrystallization of minerals into different forms. Metamorphic gemstones include jadeite, garnet, cordierite, and tanzanite. Gemstones also form in the mantle under conditions of high pressure and high temperature. The most abundant mineral in the mantle is olivine. Under the right conditions, olivine can crystallize as the gemstone peridote. In general, these are upper mantle minerals forming on the order of 50 miles deep. Diamonds, of course, form under higher pressures. They form even deeper in the mantle than peridote. Diamonds are estimated to form 150 miles deep, and they are brought to the surface via a unique geologic formation called a kimberlite pipe. As I went through the different processes of gemstone formation, I tried to touch on the various birthstones. The concept of a birthstone has its origin in the Bible. In the book of Exodus, a breastplate that Aaron wore had a circle of 12 gemstones, one for each of the 12 sons of Israel. By the 5th century AD, those 12 gemstones became associated with the signs of the zodiac. For better marketing, in the 18th century, gem traders developed the concept of birthstones, and each month was given a specific birthstone. But if your birthday is in June, you no doubt noticed I didn't mention pearls, although June also has 2 other birthstones, alexandrite and moonstone. I don't know what that says about people born in June. I didn't mention pearls because it's organic in origin. It doesn't form the same way those other gemstones form. Pearls are made of nacre, which is a calcium carbonate. Nacre is mainly aragonite, which is deposited as hexagonal platelets, which are very small. Pearls form because of an irritant inside the shell of a mollusk. The animal will secrete the nacre around the irritant to reduce the stress the irritant is causing. As the process continues, the pearl grows larger through concentric accumulation of layers of hexagonal platelets of aragonite. Pearls make beautiful gemstones and lovely jewelry, but it brings up the point, what exactly is a gem if it can include organically generated materials? That's a good question, and I think in the end the answer is beauty is in the eye of the beholder, but it also includes an economic component as well. For example, there are other organic gems. Mother of pearl is also nacre and similar in chemistry to pearls, but it accumulates on the inside of the mollusk's shell. As a result, it has to be cut and inlaid into jewelry rather than hung on a string or suspended on an earring. Amylite is fossilized iridescent aragonite that accumulated like mother of pearl on the inside of an extinct group of mollusks called ammonites. Over time, aragonite is modified and it takes on a number of iridescent colors. Amylite forms on the inside of the shell, so it has to be inlaid in jewelry. But because it's both beautiful and a fossil, it makes an interesting piece of jewelry. Amber is formed by trees. It's not sap, it's a resin produced by the tree. There are really just a few occurrences of amber that are commercially developed. Baltic amber is by far the most marketed amber for gem purposes, making up as much as 90% of the known gemstone quality amber. It formed from 65 to 23 million years ago, so it doesn't have any Jurassic Park DNA in it. Although originally collected around the region of the Baltic Sea, Baltic amber is found throughout Northern Europe. What's unique about Baltic amber is that it doesn't have a lot of fossil inclusions trapped in it. It comes in a lot of colors, and it occurs in an opaque form due to minute bubbles trapped in the resin. It's really interesting stuff. Other organic materials I've seen used in jewelry, and in fact I'm kind of a sucker for, are fossilized coral and fossilized ivory. Fossilized coral is made throughout the world. I've also seen modern coral used. The difference is usually the color. Fossilized coral has lost its pigments, but the structure of the coral and the patterns that show up in the jewelry are really interesting. And you don't have to worry. Fossil coral is abundant and mining it won't hurt the marine environment. Unlike the harvesting of living coral, the same is true about ivory. You don't want to get involved with recently harvested ivory, but fossil ivory, say from a woolly mammoth, as we have here, is often crafted by indigenous artists and is both scientifically interesting and beautiful. What else is used as a gem? At this point, I would say almost anything that looks good. Here are two examples using quartz with inclusions of the titanium mineral called rutile. This can be spectacular once it's polished and mounted. Polished metals can also be strung on bracelets. Here is the metal hematite. I've also seen magnetite and pyrite made into interesting pieces of jewelry. All really neat stuff. So, say you want to go out collecting gemstones. Right! This geology stuff is going to finally pay off. You're going to strike it rich. Let me be honest with you. Don't get your hopes up. Most beginning geologists don't recognize gemstones. Frequently, they look like just another rock or mineral. If you do recognize a gemstone in the field, you'll also recognize how much work it will take to make the specimen you are holding in your hand look like a gem. Gem cutters will use crystal characteristics to cut gems so that the impurities are removed. Gem cutters are trained professionals, and it's next to impossible for an amateur to even come close. If you're heading out looking for gemstones, you should be doing it to enjoy the time outside and the joy of collecting, not for monetary benefit. Leave that to the professionals. Looking for gems is similar to other types of fieldwork. Do a little homework beforehand so you know in advance where known collecting localities are found and what type of rocks and potential minerals you might find. Then you already know the essentials of geology fieldwork. For gem collecting in particular, you need permission. Trespassing, claim jumping, and collecting illegally are things you don't want to do. But if you have permission, in addition to the basic field gear, you might think about bringing chisels and a small sledgehammer with you. But I'll warn you, it's really hard to get minerals and gems out of a rock matrix. Here again, in most cases, it's best just to take a photo and walk away. Let me show you these garnets in the schist. They're beautiful, but I won't be able to get them out. Watch, I'm doing this for you. First, maybe I can chisel this one out. No. Sad, right? I broke the mineral and I ruined a perfectly good hand sample. The best way to collect garnets is to look in the same rock that is weathered. Here's some nice examples that have weathered out of that same rock. So that means another tool, a sieve. For a lot of hard, chemically resistant minerals, searching in sediment is the best way to go. Weathering and erosion will both expose and extricate resistant minerals from bedrock, and frequently they end up in water. In fact, a lot of commercial mining involves sifting through sediments, especially the big four: diamonds, emeralds, rubies, and sapphires. These are all very hard minerals and very resistant to wear. In many cases, commercial enterprises have been set up to sift through stream beds or beach sands. If you're paying attention to the politics of mining, you also know that those commercial operations can be very detrimental to the environment and exploitative of the workers. Unfortunately, gem mining can bring out the worst in people. Okay, so what you're hearing is not very encouraging, and that's not my usual modus operandi. Should you not go gem hunting? The answer is yes, you should, but do it at well-known collecting sites. In the US, there are lots of locations that allow you to look for and keep any gems you find. They are a lot of fun. Many people are surprised to learn that gemstones are produced in the United States. Of course, it's pretty well known that the US is a big consumer of gemstones, but production is a different story. In most cases, gem mines in the US are small-scale operations with maybe a couple of employees. But over 60 types of gemstones are produced in the United States, and they include diamonds, garnets, jasper, sapphire, topaz, tourmaline, turquoise, and others. That said, gemstone production is not evenly spread across the states. 12 states produce 90% of the gemstones mined in the U.S., mostly in big western states. Idaho, the gem state, produces the most U.S. gems. Then in order are Arizona, which is second, Oregon, California, Montana, Arkansas, Maine, Colorado, North Carolina, Nevada, Texas, and Utah. When you visit pay-to-dig gem collecting locations, you have to remember to follow their rules. Go online and learn what they are and know in advance when the mine will be open. Each one of these places should have a reasonable website. In addition to hours of operation admission fees, usually they tell you what to bring, how to dress, and what conditions you will be working under. In some, you will be digging through soil, and in others, you will be washing sediments in sluices. Dress accordingly. Not all sites admit kids, but they can be an awful lot of fun for both avid collectors and the weekend rockhound, and of course kids if they're allowed to be there. What can you find? Well, at the Barton Garnet Mine in New York, you're going to be able to find garnets of all shapes and sizes and quality. At Dig Maine Gems in Maine, they guarantee that you will find tourmaline. At the Bar M Ranch in Texas, topaz is usually on the menu, but check first to see if the place is still open. But for the 5 big precious gems, there are just a couple of collecting sites in the United States. There's one active diamond mine in the United States, and that's Crater of Diamonds Mine in Murfreesboro, Arkansas. It's an ancient volcanic complex that yields diamonds on a pretty regular basis. Collectors find a few hundred carats per year. In 2015, an 8.5-carat diamond was found with an estimated value of over $1 million. It's called the Esperanza. It's the most valuable diamond ever found in the United States. You probably won't find a diamond that size, but Crater of Diamonds Mine is a lot of fun. You don't need much equipment because you can usually just spot diamonds in loose soil, and you get to keep what you dig. The Emerald Hollow Mine in North Carolina is the only emerald mine in the world that's open to the public. It's open almost every day of the year and has a number of activities, including activities for kids. The mine has yielded not just emerald, but aquamarine, sapphire, topaz, citrines, and many other gems. The town is named for their most distinctive gemstone, hiddenite, a rare green form of the lithium ore called spodumene. In western Montana, there's a Gem Mountain sapphire mine in Phillipsburg with some of the same geology as nearby Idaho. They specialize in sapphires, and you get to pick through coarse gravel searching for the stones. The particular sapphire variety is called the Montana sapphire. Here too, there are people at the mine who will help you polish up any stones you find. Rounding out the 5 precious gems is opal, which is offered at several pay-to-dig sites in Nevada. For example, you can mine your own at the Rainbow Ridge Opal Mine in Nevada. At this site, you have to bring your own tools and buckets. Also, you have to work to get good specimen. but stones worth up to $50,000 have been recovered there. There are many more, and you can find them online. Some have gemstones, others have high-quality mineral specimens. The prices vary, but as I say, they can be a fun thing to do. Very rarely do I get asked about possible gemstones that people find. On the other hand, very commonly people bring rocks to me that they think are meteorites. On average, I get asked about a possible meteorite once or twice a month when the ground isn't snow-covered. People have been showing me their finds for the 30-plus years I've been at the University of Minnesota Morris. I have never been shown a meteorite. This is really common. There are several universities with meteorite websites, including the University of Minnesota, that talk about meteorites and how to identify meteorites. Many of those sites state emphatically that they don't have the faculty available to look at every presumptive meteorite. The website I like best is the University of Washington at St. Louis. It's very informative, but I'll warn you, it's a little bit harsh in its urging of people to look carefully at the characteristics of the specimen that they find. They used to use the term meteorongs to describe the samples that people bring in thinking that they are meteorites, but they stopped using that term. So if you're looking for a meteorite, what are you looking for? One type of meteorite is called an iron meteorite. They're heavy and dense, and they don't look like a normal rock. If an iron meteorite hasn't weathered substantially, it will attract a magnet. Iron meteorites are the easiest meteorites to spot, so they make up about 2/3 of the meteorites that have been found on Earth. But astronomers claim that iron meteorites make up less than 10% of the meteorites that fall to Earth. There's a bias created by the recognizability of iron meteorites. They don't look like rock. They look like a lump of iron. The most common meteorites to fall to Earth are stony meteorites. They make up over 90% of the meteorites falling to Earth. However, stony meteorites look like Earth rocks, so people rarely find them. Meteorites frequently have what's called a fusion crust, which forms from heat and abrasion that occurs as the meteorite enters the atmosphere. But over time, a fusion crust can weather away. Also, meteorites have small indentations that are called rhegmaglyphs. These look like a fingertip indentation in soft mud. They are also caused by abrasion. If you look at a map of the distribution of meteorite finds, they are overwhelmingly in the American Southwest. There's a reason for that. If a meteorite falls in a forest or a grassland, it is going to be really hard to find. It's also hard to find meteorites amongst other rocks. So if you can find a location where there's either desert sands or a dry lake bed, any surface that doesn't have a lot of rock strewn about it, that's a good place to start. Remember, desert fieldwork requires precautions. Always have enough water, be dressed appropriately, and have a field partner. It's safer and it makes meteorite hunting more fun. Some folks recommend bringing along some sort of magnet, but overwhelmingly, meteorites are found just by eyesight alone. Bring a sample bag and be patient. As with any collecting, make sure you have permission to collect. Ownership laws for meteorites are a bit ambiguous, but if you're on government land that you are allowed to be on, there's a good chance you can keep a meteorite if you find it. This is unlike vertebrate fossils or human artifacts, which you are not allowed to keep. So say you find something that you think is a meteorite. The quick and dirty things to tell you it's not a meteorite are, does it have quartz or feldspar? Meteorites don't have those. Does it have holes like vesicles in a volcanic rock? If it does, not a meteorite. Does it have layers? Meteorites don't have layers. What in fact did you find? A lot of times, desert varnish like this is mistaken for fusion crust. This is a good example of desert varnish. Desert varnish, also called rock varnish, forms in dry environments where meteorites can be found. But desert varnish is a buildup of windblown clay and manganese on the outside of normal terrestrial rocks. It's a common feature on rocks. Here is a sample of industrial slag. Slag is a byproduct of iron making. It's often confused with meteorites. Slag is frequently both magnetic and dense. Finally, many igneous rocks or metamorphic rocks, when weathered, can look like meteorites. Here's an example. Using the diagnostic pages on the University of Minnesota or University of St. Louis meteorite websites, you can do some tests yourself. At this point, you know enough geology to determine if it's a meteorite. Disappointingly, it will probably not be. Iron meteorites are often made into jewelry that display the classic patterns called Widmanstätten patterns. Stony meteorites are also made into jewelry, but look a lot like earth rocks. Here are a couple of examples. Rocks impacted by meteorites are also used as gemstones. Tektites are made of terrestrial rock, and frequently they are silica rich. When a meteorite hits the earth, there's enough force to generate pressure melting temperatures. The rock material that is struck by a meteorite is melted and then ejected away from the impact site. Tektites are a glassy impact melt product. They make up part of the terrestrial rock debris that's hurled out of an impact crater. The rapid cooling of tektites as they are launched results in glassy characteristics that jewelry makers are attracted to. Moldavite is a specific type of tektite. It has a distinctive green or blue-green glassy color. Moldavite only formed during a single event, a meteorite impact that probably occurred in southern Germany 15 million years ago. Moldavite is probably the most highly valued tektite out there. So remember, you can find gems and minerals, but even if you don't, it's fun to get out there and look. Whether it's a mineral or a meteorite or some other rock, it probably comes in jewelry form or could be made into something. If you like it, wear it. Who knows, it might start a conversation. Maybe you'll find another person who enjoys geology and may even want to do fieldwork with you the next time you go hunting for gems or meteorites.